All right, section 4.4, analyzing lines of fit. So in the last section, we drew our lines of fit. We drew our dots. So like over here, we have our data points, and then we drew the line. We drew the line that fit those data points as best we could. Today we're going to be analyzing them, determining how well do our data points actually fit the model. And what we mean by model is the equation that we came up with. The equation we came up with for the data points. Okay, and again, a reminder, please write down all the notes I write. Please write those down. Okay, excuse me. Okay, so that's going to be the first part of this video. So the best way of analyzing how well the model fits is to look at their residuals. The residual is the difference of the y value of the data point and the y value, okay, of the line that we wrote. Okay, it's the difference of the y value of the data point and the y value of the line. So in this case, in this example over here, here's our line, here's our data point, and here's the y value on that line. So in this case, this residual, okay, we'll stick with blue. My data point's above this line, so this residual is positive. It'd be a positive 3. You can tell there the difference there is 3 because there's 3 apart from those two. Okay. Whereas in this one over here, this residual is negative because my data point's below my line, so that would be a negative 2. Okay. For it to be a good fit, you want the residuals to be small numbers, and you want them evenly dispersed on either side of 0. Okay, and so the easiest way to look at these is to graph the residuals. So we're going to graph them. Start right there. Make sure you graph those residuals. That's the best way to determine whether it fits the model. Okay, so let's go ahead and let's jump right into an example. Okay, example 3 in section 4.4. So in our last section, we came up with an equation that models the data in the table. And so they came up with this equation here. So this right here is our model. This over here is our data set. Okay, so I need to take my model here, this model, and I needed to come up with the y values for each of these x values over here. So I'm going to create one more column, and I'm going to call it my model values, my model y values. And we're going to go ahead and we're going to come up with those. Okay. So I need to put a 1 into this function for x and see what y is. So I'd have negative 2 times 1 plus 20, which gives me 18. Okay, so then the residual would be this last column over here. Okay, so this last column is what we want to call the residual. And the residual then would be the difference. It would be that 19 minus the 18th, so that the residual is 1. And then we're going to keep doing that for each of these data points. So now I'm going to put in a 2. Negative 2 times 2 plus 20, which gives me 14 plus 20 is 16. Okay, so I'm just going to come up with each of these. So now this, again, we're putting these values in, this 3. Negative 2 times 3 plus 20 gives me 14. Negative 6 plus 20. Negative 2 times 4 plus 20. Negative 8 plus 20 is 12. Negative 2 times 5 plus 20. Negative 10 times 20 is 10. Negative 2 times 6 plus 20. Negative 12, plus. Negative 12 plus 20 is 8. 7. Negative 2 times 7 plus 20. Negative 14 plus 20 is 6. And then negative 2 times 8 plus 20. Negative 16 plus 20 is 4. So now we want to do all the residuals, the difference. So this would be, so this was, again, the 19 minus the 18. So then we'll go 15 minus 16. That's negative 1. 13 minus the 14 is negative 1. 11 minus the 12. 10 minus 10, that residual is 0. 8 minus 8, that's residual 0. 7 minus 6 is 1. 5 minus 4 is 1. So my residuals are these numbers right here. Okay, so we are going to graph those residuals with these x values. Okay, so we are going to graph those residuals. So I need to create my table. Looks like we're just positive x's, but we've got positive and negative y's. So we're kind of going to do both. So we're going to graph these residuals. So this would be the point 1, 1. Oh, 1, 1. This one, this one. So you have the point 1, 1. Okay, and then we have the point 2, negative 1. 3, negative 1. 4, negative 1. 5, 0, 6, 0. 7, 1, 8, 1. Okay, so this is a graph of our residuals. Okay, first of all, we want all our residuals to be small. All of these residuals are in between negative 1 and 1. So it's a small interval, which is good. Are they evenly dispersed on either side of 0? Well, we've got 2 of them on 0. We've got 3 of them above 0. So we have 3 above. But look here, we also have 3 below. So yeah, they are evenly dispersed. So since they're evenly dispersed and small in between 1 and 1, we say it's a good fit. It's a good fit since residuals are evenly dispersed. Even if they weren't all small, like let's say I had a big one up here, if I had another big one down here, then yep, we would say they're still evenly dispersed. Okay. All right, so let's go ahead and let's look at another one. Okay. Again, we're going to come up with those residuals. So we need to come up with a model value. Okay. So the table shows the ages X and salaries Y and thousands of dollars of 8 employees at a company. The equation, so there's our model right there. Y equals 0.2x plus 38. So we're going to create a model table for the Y equals 0.2x plus 38. So we're going to add a column in our table. And then we'll also add a column for our residuals. Tables are very helpful here. Okay, so then we'll add a column for our residuals. Okay, so I need to put a 35. So I'm going to have 0.2 times 35. I think I'm going to do these using a calculator. Oh, sorry. Oh, is it not going to let me? Okay, using my calculator. Okay, maybe it'll let me. Okay, so we need 0.2 times 35 plus 38. And we get 45. Okay, and then now we need to change that. Instead of 35, we're going to do 37, which is 45.4. And then we need to change that to a 41, which is 46.2. Change it to a 43, which is 46.6. Change that to a 45. Look how nice Desmos makes this. 47, 47.4, 53, 48.6, and then 55 is 49. So there's all my value points. Again, so this guy over here, this guy right here is just my model, 0.2 times x plus 38. Okay, and then I just put those values in. Now I need to find the difference. So I need to subtract, okay, I need to subtract the salary minus the model value. Okay, so I need to take 42 minus 45. I know that one's a negative 3. Go with my red. So we know that one's a negative 3. So 44 minus the 45.4, that one's negative 1.4. And then we need 47 minus 46.2, 0.8. 50 minus 46.6, 3.4. 52 minus 47 is 5. 51 minus 47.4. We could have done the one in my head, 3.6. 49. 49 minus 48.6 is 0.4. And then 45 minus 49 is negative 5. Oh, negative 4. Typo. Okay. All right, so now that we have all the residuals, we want to graph them. Okay, so we want to go ahead and graph them with our x's. So we're going to use these guys for x's again, and these guys for our y's. So these are our x's, these are our y's. Okay, to graph those residuals, just to see what they look like. Okay, so all my x's are positive and they start at 35. So I'm going to go ahead and I'm going to do a break in my graph, kind of put a zigzaggy to show a break. And I think I'm going to count by 5s. Okay, so here we'll go 30. We'll go that's 30, 5, 10, that would be 40, so forth. 5, 10, it'd be 50, and that'd be 55. Okay. Okay, and then, but it looks like all of these are fairly small, so we're going to go 1, we'll count by 1, 2s, and 3s on that axis. So make sure you label your axis how you're counting. So for 35, we're at negative 3. So 35, down 1, 2, 3. Okay. At 37, so just a little bit past 35, we're at negative 1.4. So negative 1.4, almost negative 1.5, we'd be right about there. Okay. At 47, at a little 47, a little past 45, 41. Look at the right x's. At 41, we're at 0.8, so almost 1 there. At 43, we're at 3.4. So 1, 2, 3.4. Okay. At 45, we're at 5. At 47, we're at 3.6. At 53, we're at 0.4. And at 55, oh, that should be 60 there. Typo. So then at 55, we're at negative 4. Okay. This kind of makes a bit of a pattern. It's kind of going up, turn around, come back down. So since it makes some kind of pattern and they're not evenly dispersed, let's get rid of my red dots. Okay, it does make this kind of pattern. It kind of goes whoop and back down. Okay, since it makes this kind of pattern and it's not evenly dispersed, if you notice, there are how many above? There's one way up here, but there's 2 that are way down here. And we've got 1, 2, 3, 4, 5 above and only 3 below. So this is not evenly dispersed. So is the model a good fit? No, not evenly dispersed. Okay, it actually makes a pattern. Since it makes some kind of other pattern, that makes us think that it's probably something not linear. There are other type of functions besides lines. So it's not evenly dispersed. It makes a different type of pattern, so it's probably not linear. Okay. So now I want you to go ahead and I want you to do problems 6 through 10 even on page 206. Okay, so on page 206, 6 through 10 even, you're going to need graph paper because you're going to be graphing residuals. Come see me if you need help.